Hey, how's it going? This is Doug Wilklow. I'm doing my Spring 2021 Control of Mobile Robots Lab 2 presentation here. The first couple tasks I got done really pretty well. I spent a lot of time on all of these, but I wasn't able to get all of them perfectly working. However, this one does work the way it's supposed to. Here is the KP array where you choose which of these KPs you want to use. The default is 0 because that seems to be the one that works the best. Essentially, what it does is it takes in the left and the right sensor, it detects the difference, and it adjusts the speed of the left and right wheels accordingly so that it kind of wiggles its way over in the appropriate amount of time to around there, 10 inches from the final wall there. Heck yeah, dude. All right. So here is the distance I have it covering, 40. The time in seconds I want it to work in, which is 30. If you want to see it like actually, if you want to see a better example of how this works, you can actually lower this to 15 seconds just as easily, and it'll still work on all 5 of these. And it looks a lot better too. But let's bump that to 5. Okay, see the wiggle? All right, stuff's just short. Perfect. So essentially what it does is it gets the right, left, and front proximity sensors here for like initial values, and then each step it gets a new version of it and replaces the current with previous, or replaces the previous with the current values, so that each step it can compare the current left to the previous left and the current right to the previous right, see which one is changing, which one's going up, which one's going down, and adjust the wheels. That's pretty much it for task 1 though. Yeah, on the lower KPs that you can barely see it's wiggling at all. All right, so this one's already starting. Essentially what it does is it'll spin around for a sec. It'll wait until it sees the cylinder, and it will then accelerate the wheels in such a way so as to point directly at it and eventually stop 10 inches away from the cylinder. I actually, at first, did not know you could use data from the object that's being read in the camera, like a camera recognition object. I didn't know this object existed at all in the initial version of this, or I was just using the camera and whether or not the object had entered the frame, like this. So found equals camera.getRecognition number of objects, where if it was 1, that meant I had found the cylinder either entering from the left or the right side of the screen, and according to that, I could speed up the wheels in such a way that it wound up in the center. But that was really kind of janky. It still does a similar thing to that, where it'll still adjust the wheels in that sort of way, where it'll, from the side of the screen, spin the wheels up to speed so that it kind of ramps up in that same way. I'll show it again. But like this. So the wheels speed up in just such a way so that this winds up in the very center and just keeps going straight toward it. But having the get recognition object, or camera recognition object, is very, very handy for this, because that allows me to get the actual perfect location of the pillar, which is right here. Pillar position 2, or index 2, which is get position, which returns an array, which is that relative position, those 3 values there. That third one's the important one. That is the actual distance from the camera. And we use that to stop exactly 10 inches from the post. Task 3 is a tricky one. You can see it going down here. I'm just going to let this play out in real time while I explain what I did. Essentially what I had to do was this very similar check, or series of checks, to the hallway, the task 1. But the problem, which we're going to see right here, is when you run into a spot where the turning happens, and it goes in, and the sensor is reading the same exact, or roughly the same amount, no matter what point in the turn you're at. So like it does like a radius around that point where it's hitting the wall, you know? That is a nightmare. That is an actual nightmare, which I have tried to work around by making it so that... What did I do with that? Oh yeah, I set it up so that if the wheels are running it at a wildly different speed, it will stop that and then just kind of adjust the wheels to return to similar speeds down here. We're just gonna let that run. You can see it kind of stutter a little bit almost. But this one's very janky, but it will eventually get through a corridor probably. Probably. It'll eventually get through a corridor. It does this a lot, where it goes back and forth between two walls diagonally like that. And since it's in the turning step, since I didn't want it to stop halfway through, because then it would just keep bashing into walls. So while there, it's like just barely too far away for that left sensor to go off. So it'll just keep doing this over and over again. Big nightmare. But I did get it kind of working. It does kind of work on some values of KP, which is nice. That's what I was able to get going here. This took days. this took days and days. Just wild. I just don't know how. Like, looking up stuff for Weebots is very, 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 very difficult. 0 works the best. Look at that. Crazy. Oh boy, it's getting funky over here. I wound up making a very, very large series of if statements, which is extremely sloppy, and I apologize for whoever has to read that. But by the time I had gotten to about halfway through this, I had sunk too much time into it to go back and make it all functions. This is like I gave myself again like a week to get all of these done, and that was not enough time. I had a week of like several hours a day, like 4 or 5 hours a day, just like sitting here looking at Weebot's documentation online, and stuff like that. It just didn't work out. Very unfortunate. But yeah, that's task 3. I essentially only did the corridors, and I did the left and the right. Right kind of works a little better, which is interesting. You can see that it's basically the same thing, but it just works better for some reason. The initial position of the robot probably helps out. Task 4 works very similar to Task 2, where it'll get stuck right there. Essentially, it likes to find the pillar. No matter where you put the puck at the start, it'll try to find the pillar, which is nice. It's something I messed around with for a couple of hours to make sure it actually worked correctly. Or like it'll do a full rotation, find the pillar, and then start moving. It does that same thing where it revs up the wheels so it winds up going in a straight line almost. Then it hits a wall, and I don't know how to... I have 0 clue what to do with it. However, if you take it and put it all the way over by the pillar there, it'll actually find the pillar, just drag itself straight there. And just like Task 2, it'll stop 10 inches away. So right about here, probably. Oh, hey, that works. That's probably 10 inches from the center of it, maybe. I'm not sure. Either way, it does somewhat work. It just doesn't do exactly what it's supposed to do. It's just bigger than I thought I was going to be by a wide margin. All right, and that is about it for all of my Lab 2. I apologize for the sloppiness of this code. It's not my finest work. However, I hope you have a good day, and thank you for your time.